Hello, my name is Mitov, the president of Mitov Software, and in this session we will demonstrate developing Windows and Android applications with the cross-platform Mitov Software component libraries. Mitov Software offers a wide variety of products. Of those, the following are Windows and Android compatible. Visual Live Bindings, a universal Visual Live Binding library, is completely ported to Android. LogicLab, a Boolean logic library, is completely ported to Android. And AnimationLab, universal animation library, is completely ported. IntelligenceLab, a artificial intelligence library, is practically completely ported. However, we still have to finish a little bit more work on one last component before we can declare it 100% completed. PlotLab, a data visualization library, is in process of being ported and should be available in the next couple of months as well. Currently, the rest of our products are Windows only, however, they also will slowly be ported to Android. Those are VideoLab, a video processing library, AudioLab, audio processing library, SignalLab, digital signal processing library, VisionLab, a computer vision library, InstrumentLab, a visual instrumentation library. We also have OpenWire Studio, which is a standalone integrated graphical development environment. We'll start the introduction with Visual Live Bindings. Visual Live Bindings was the first Visual Live Binding library for Delphi ever introduced. It binds using OpenWire, a open source library also developed and maintained by Mitov Software. It can bind complex objects, it is thread safe, and it can integrate directly with all of the Mitov Software products. For our first demonstration, we'll start with a FileMonkey application. We'll drop a checkbox and a button. We'll right-click on the checkbox and select New Visual Live Bindings. Here, we'll filter to the isChecked property and we'll assign a source pin. Then we'll do similar thing for the button. Here we'll search for the enable property. And we'll assign a sync pin. Now we can switch to the OpenWire view and we can connect the isChecked with the enabled. We'll run the application in Windows. You can see that we can control the enabled state of the button by checking and unchecking the checkbox. We did not need to write any code for this. Now we can switch to Android and we can recompile the application again. Our application is ready to run on Android device. Since I am working from inside virtual machine, I am unable to run and demonstrate it in the Android simulator, and I am unable to show the screen of my external device. However, I can assure you that this code runs on my Nexus 7. Now let's take a look at a more interesting example. In this case, we'll start with client dataset. We'll select database for it. We'll drop string grid and navigator. Next, we'll add again some visual live bindings. We'll start with the client dataset. We'll add a source pin to it. Then, for the string grid, we'll add sync pin. And for the bind navigator, we'll add another sync pin. Now we can switch to our OpenWire view and connect them. Our dataset is already connected and working with the string grid. Let's run the application. As you can see, all of the components are working properly together. Next, we'll add edit box. And a label. We'll add pins to both of them. For the edit box, we'll add state pin for its text property. For the label, we'll add a sync pin for the text property. Next, we'll add all the fields to the dataset. For the record number of the dataset, we'll add a source pin. Next, for the category field, we'll add a string state pin. Now we can switch to the OpenWire view and we'll connect the label to the record number so we can see the number of the record currently selected in the dataset. For the edit, we'll connect it to the client dataset category. And we'll rearrange the components to see them better. Now let's run the application. We can see the current record being displayed on the label. We can edit the category field from the edit box or directly from inside the string grid. And our navigator still works, including cancel and confirm operations. Next, we'll do some more fun stuff. With visual live bindings, we already saw that we can add pins to components and properties and then make connections between them. Those components and properties are not limited only to the components on the form, but we can access any public or published property on the form itself. So let's add pin for the caption of the form. And we'll connect it to the species name. We also will add a couple of more pins. The length in inches, we'll add a state pin. And for the width of the edit one, we'll add a sync pin. Now in the OpenWire diagram, we'll connect the caption to the species name and the width of the edit box to the length in inches. Let's see it running. You can see that our edit box is changing its width based on which element in the database is selected, and we can see also that the caption of the form is changing accordingly. Let's add some more interesting elements to the form. We will add a T image and 3D viewport. Next, we'll add a round cube in the viewport. We'll add light and light material source. We'll arrange the components. We'll select material source for the cube. Then we'll add OpenWire pins. For the bitmap of the image 1, we'll add stream persist sync pin, as well as for the light material source. For the graphic field, we'll add stream persist source pin. We'll switch to the OpenWire view and we'll connect them. Let's run the application. You can see that the graphic field is used to populate both components. To make it more interesting, next we'll add pin to the width property of the round cube as well. And we'll connect it to the length in inches. Let's run the application. You can see that everything is working properly, including setting the width of the round cube. So far, we demonstrated linking properties and components with the OpenWire pins. The OpenWire Visual Live binding, however, allows connect. Not only that, but also adding pins to events and any public method, as well as linking them. Let's try that. We'll add two buttons. And we will add pins to their on-click event. Then we'll add pins to the next and previous method of the client dataset. And we'll connect them with OpenWire. Let's run the application. Now we can navigate our database with our newly added buttons, so we can handle events without the need to write any code. This is not all. There is vast amount of other functionalities in the Mitov software's visual live bindings, simply not available in any other live binding product whatsoever. However, we'll display some of the most useful ones. Sometimes we want to use a list box and display all of the elements of a particular field. Let's do that. We'll add list box and we'll add visual live binding for it. We'll go to the items of the list box and we'll set a sync pin. Next, we'll select the command name field and we'll add tstrings source pin and we'll connect them. Let's run the application. Here are all of the records for the command name field. All of this up to this point was demonstrated on Windows. Let's see if we can compile it for Android. You can see that the build went successfully, and now we can run the same application on Android. In addition to all this, we can link our database with the rest of our other products. Since they are not fully ported to Android yet, we will do this in Windows. We will drop a scope component. Then we will add OpenWire pin to the length in centimeters field of type RealList. Now we can go to the OpenWire and connect this field with one of the channels of the scope. Now the scope is connected to the field. Let's run the application. You can see that the scope is properly populated with the values from the field. In our next demo, we'll demonstrate direct linking between VideoLab and Visual Live bindings. We'll start with a video player and we'll add a viewport. In the viewport round cube, like and light material. Next, we'll select video to play in the video player. And we'll open the Visual Live Bindings editor. And we'll add stream persist to the light material source. Now we'll switch to the OpenWire editor and we'll connect the video to the light material source. Let's run the application. You can see the video playing as texture of the cube. We can even add rotation to the cube. We will add a sync pin for the Z rotation angle. And we will connect this pin to the progress. Let's run it. You can see our cube rotating as the video progresses. Using VideoLab with Visual Live bindings surely is a lot of fun. Next, we'll demonstrate AnimationLab. AnimationLab can animate any property through the Visual Live bindings. It can be used to animate both visual and non-visual components. It contains timeline and simple physics engine. Again, we'll start with a FireMonkey application. We'll drop timeline and we'll open the timeline editor. Next, we'll add a couple of channels to that timeline. We'll add 2 real channels. We can also add integer channel, but we'll not demonstrate this in the current demo. With AnimationLab, you can have many channels with different types, such as real integers, and we are working to add color and other types. Each of the channels has periods. We can edit those periods. Currently, we can add only linear interpolation periods. We are, however, working to add other forms of interpolation. So let's add a couple of periods to the first channel. Then we'll select the second channel and we'll add a couple of periods. Let's do 3 periods for this one. Let's extend the length of this period to 1.5 seconds. This is the interval in seconds. Let's select the first period and set the value to 20. Then select the channel and set the initial value to 100. Finally, for the second period, let's set the value to 200. Select the second channel and set some initial value. Then select the first interval and set another value. Second interval, another value. And for the last interval, another value. Here we have 2 channels in our animation sequence. Next, let's connect those channels to some properties. For this, we'll drop a button. And we'll add a couple of pins to it using visual line bindings. For the X and Y position. And we'll connect the button to the timeline. We'll set the timeline to loop. And since it is enabled, the animation will start as soon as we start the application. Let's run it. You can see that our button is animated. Now let's disable the animation and add pins to its start event and the on-click event of the button. Now we'll connect them. Let's run the application. If I click my button, the animation sequence will start. It is set to loop, so it will go indefinitely. Let's disable the loop and run again. You can see that our animation starts as soon as we click the button. Next, we'll add some physics effect. We'll add mass to the button. We'll add the mass in the x-axis. Now our button has a mass and thus inertia. We can also add mass to the y-axis, or we can add drag to it. Now the component has drag on the y-axis and mass on the x-axis. Equally easy, we can animate three-dimensional objects. We can add a viewport and round cube in it. Light source, and some light material. Then we can select one of the rotation axes and add pin to it. Then we can connect it to one of the channels. You can see that the cube gets animated. We can also connect it after the mass has been applied. Or if we wanted, we could have added it its own type of mass. You can see that the mass effect is working. All this also works in Android. We can come here and change the target to Android, then build it for Android. You can see that it builds just fine, and it will run. This concludes our session. My name again is Mitov, the president of Mitov Software. You can see my email here, mitov@mitov.com. Our website is www.mitov.com. We offer a wide range of products, including VideoLab, video processing library, AudioLab, audio processing library, SignalLab, digital signal processing library, VisionLab, computer vision library, PlotLab, data visualization library, InstrumentLab, visual instrumentation library, IntelligenceLab, artificial intelligence library. We are nearing the release of LogicLab, Boolean logic library, AnimationLab, universal animation library. We also offer Visual Live Binding, universal visual live binding library, and OpenWire Studio, a standalone graphical development environment. We also maintain two open source libraries, the OpenWire library and the iGDI Plus library, a Delphi-friendly GDI Plus library. Thank you for listening, and now it's time for questions and answers.